Alright, on this video we're going to introduce when we have an exponent that is 0. Maybe you know what this equals, but really in order to establish what this equals, we're just going to have to look at division right here. Now, you see I have these examples, and I started with this real easy example. If you have 5 divided by 5, well, that's pretty easy right there. That's just equals 1. Okay? And it's kind of, really, it's just like saying 5 to the first over 5 to the first. So if you actually subtract, you're going to keep the base of 5, but if you subtracted these exponents of 1, 1 minus 1 gives you 0. I know 5 divided by 5 is 0, so I've proven that 5 to the 0 equals 1. Okay, if you take x over x, well, if you divide the same thing, if you take a number and divide it by the same thing, well, they're all going to cancel. This is going to equal 1. Same thing if I did x squared over x squared, they're going to cancel out. This is going to equal 1. It's going to give you the same quantity. And if you use the rules for division, you subtract the exponents. We haven't seen this happen before. Now if it's the same, you get x to the 2 minus 2, which gives you x to the 0. I've proven that that equals 1. So what I've proven here is that any number raised to the 0 always equals 1. So put that in there. Okay, it's one of those mathematical things that looks a little bit more difficult than it is. Some students probably always want to think it's 0 because they think they're multiplying by 0, but you're not multiplying it by 0, you're raising it to 0, and it's always going to equal 1. Okay, let's just do these 3 problems, and that'll be it. Number 1, well, I'm still going to do the same thing. I'm still going to divide, so I'm going to subtract the exponents. If I look at x is bigger in the bottom, so I'm going to have x in the bottom, and 7 minus this 5 gives me 2. So I have x squared in the bottom. Now the y's, these are the same. So really I could just cancel them out. They go away. Or you could say y to the 0, but that kind of gives you more work. That's the same thing as 1. They just go away. Everything canceled out in the top, so it's 1 over x squared. Okay, no, I do number 2. I have x, y's, and z's. So let's look at x. X is bigger up top. It's x to the third over x to the first. So I'm going to have x up top. And 3 minus this 1 gives me 2. So x squared is up top. So I'm done with the x's. If I look at the y is bigger in the bottom. This 4 is bigger than this y to the first. So I'm going to have y in the bottom. And 4 minus this 1 gives me 3. So I have y cubed. So I'm done with the y's. Now this z right here, this really doesn't mean anything. 0 to the, or z to the 0 this is just like saying 1 over z to the 4th. So really, or the other way to look at it, if you did 4 minus 0, it still gives you 4. So you still have z to the 4th in the bottom. So a lot of times it doesn't do anything. So that's your answer for 2. Okay, if I look at 3, now I throw numbers in here. Always take care of the coefficients first. 4 over 6, that would reduce to 2/3. So I'm done with 4 over 6. Okay, if I look at the x's, again, really this x to the 0 really doesn't mean anything. If I do 3 minus 0, well, I still get x cubed in the bottom. So I'm done with the x's. Okay, if I look at y, 8 is bigger up top than the y to the first. So I'm going to have y in the bottom, and 8 minus 1 gives me 7. So I have y to the 7th. And then, so I'm done with the y's. And then the z, well, same thing. I have 3 over this 0. It's like saying z cubed over 1, which is just z cubed. So I'm going to have z up top. Or if you look at it, 3 minus this 0 gives me 3. So you can see how anything raised to the 0, it automatically equals 1. It really doesn't change a whole lot, especially if you're multiplying. Just don't think that if you take a number and you raise it to the 0, it equals 0. Main thing, any number raised to the 0 always equals 1.